We've been talking about your enzymes catalyzing chemical reactions, meaning they make reactions go faster. Now, this is kinetics, right? It's all about kinetics when you talk about reaction rates. Now, it is helpful if we look at what we call the reaction coordinate diagram to understand how enzymes work, or to make a general statement of how enzymes work. So number one, enzymes do not affect the equilibrium of a reaction. So recall, when we talk about equilibrium, we use what we call the equilibrium constant, capital K, which is a ratio of the concentration of your product to the concentration of your reactant. And since this is a ratio, it means that if K is greater than 1, then when the system reaches equilibrium, you will have more of the product, and we say that the product side is favored. Now, if K is less than 1, at the state of equilibrium, you have more of your A, and we say that at equilibrium, the reactant side is favored. So enzymes do not change the value of this equilibrium constant. So what does an enzyme do? An enzyme an enzyme changes the activation energy of a chemical reaction. So if we have the uncatalyzed reaction, so your substrate transforming into your product, so we have a single step shown by the black graph in this reaction coordinate diagram. The activation energy is very high. The activation energy is the difference between the peak and the energy of your substrate or the reactant. Now, in the presence of your enzyme, the reaction can take this form. So you have the formation of your enzyme substrate complex, followed by the transformation into your enzyme product complex. And the last step is the release of the product from the enzyme. So instead of a one step, we see three steps. So the first step is the formation of the ES. The second step is the formation of the EP. And the last step is the release of the product from the enzyme. And we notice in this general reaction coordinate diagram, the activation energies of these three steps are all lower than the activation energy of the uncatalyzed reaction. And this is how enzymes work. They lower the activation energy of the chemical reaction. Now, an important theory that can be used in enzyme kinetics is the transition state theory. In the transition state theory, we describe what is called the transition state from the name itself. So this is the state of our system at the peak of our reaction coordinate diagram. Now, this transition state is not a real chemical species, so you cannot isolate a transition state of a chemical reaction. So it's just something that you imagine as how your system would look like. In this case, for example, we can imagine a transition state between the substrate and the product. So this can be described by some bonds that are almost broken and some bonds that are almost formed. That's how you describe your transition state. So in the same way, in the catalyzed reaction coordinate diagram, then we can imagine the transition state between a substrate, a free substrate, and a substrate that is bound or not yet bound to the enzyme, but almost there. So that's your transition state.